This is the Spicy 100 question 4. This one's a good one. The recommended time for question 4 is 6 minutes. It is a non-calculated question. So, a bag contains only blue and red counters. There are 4 more red counters than blue counters. 2 counters are picked from the bag without replacement. The probability that one of each colour is picked is found to be 16 over 33. Find the initial number of blue counters in the bag. So if your time is set, you're feeling confident, get stuck into question 4. This is a probability question. So we have blue and red counters, and it says that there are 4 more red than blue. We are trying to find out the number of blue. So what we can do is if we use a variable, so if I said x is the number of blue, then because we know there's 4 more red, x plus 4 would be number of red. Then that means the total would be the sum of these. So x plus 4 would be 2x plus 4. And that's your total. So these are important things in these type of questions to start creating some algebraic expressions. 2 counters are picked without replacement. So you pick one, you don't put it back. So that means that the probabilities are going to change subtly. So let's draw a tree diagram. So when drawing a tree diagram, we should put the events on the end of the branches. So we're either going to get a blue or a red. And we should put the probability on the branch itself. So the number of blue would be x, because there's x blues, out of the total number, which is 2x plus 4. And then for red, it would be x plus 4 out of 2x plus 4. So that's our first pick. There are probabilities, so everything's in terms of x now. Now if we go to our next branch, so we've got blue and red again, blue, red. If we pick a blue the first time, there would still be the same amount of reds, but the total would go down. So the probability for the reds on the second pick would be x plus 4 over 2x plus 3, because the number of beads in the bag will decrease by 1. We could look at the blue option, but because the question says that the probability of one of each colour is this, I'm only going to deal with those branches. I'm not going to waste my time looking at the other ones. So we want blue then red, one of each colour. If we look at red then blue, so we would still have the same amount of blues in there, so that would be x. And again the number in the bag would go down to 2x plus 3. So what we can see then is that we can calculate in terms of x what the probability of getting a blue than a red would be. And you multiply down your branches. So if we were to multiply these together, you're going to get x over 2x plus 4 multiplied by x plus 4 over 2x plus 3. We'll also do the same for red than blue, and you'd have x plus 4 over 2x plus 4 multiplied by x over x plus 3. And what you should notice, hopefully, is that they're actually both the same probabilities. With multiplication, you can flip them round. So 2 times 3, for example, is the same as 3 times 2. So here we can say that these two probabilities are actually the same. X times x plus 4 is the same as x plus 4 times x, and they both have the same on the denominator. So effectively, the total probability, we could say, for getting one of each colour, so the probability of a red and a blue is going to be 2 lots of x multiplied by x plus 4 divided by 2x plus 4 multiplied by x plus 3, because there's 2 of them if you add them together. The 2 goes on the numerator, because if you're multiplying something by 2, it goes on your numerator. We can now equate that, because we know that that should be equal to 16 over 33. We now have an equation that we now have an equation in terms of x for us to solve. So if we simplify through, so we've got 2x here and we've got 16 over 33. So if we divide both sides by 2, we'll end up with 8 over 33. Makes our numbers a bit smaller. And if we then multiply out our brackets, so you'll get x squared plus 4x on your numerator. And then multiply that, so we're going to get 2x times 2x is 4x squared. 2x times 4 is 8x plus 6x, so plus 14x. And then 3 times 4 is 12. And then we'll have 8 over 33. Now, whenever you have an equation, you have fractions equal to a fraction, we can actually get everything on one line by just cross multiplying. So if I times the 33 up, multiply it to this side, and multiply the 4x squared plus 14x plus 12 up to the 8, we'll get the following. 33x squared plus 4x will be equal to 8 4x squared plus 14x plus 12. So if we multiply out our brackets, so we're going to get 33x squared. 33 times 4 is 132x. Then we're going to get 8 times 4, which is 32x squared. 8 times 14, so 8 tens is 80, 8 fours, so we're going to get 112x. And then 8 times 12 is 96. So we've got a quadratic equation. Let's move everything over. So 33x squared, subtract 32x squared is a single x squared, so that's nice. 132x, take away 112x is 20x. And there's subtract the 96, so that's come through nicely. So what we're doing is we're looking for a couple of things that multiply to make negative 96 and add to make 20. So 4 multiplied by 24 is 96. So if we have x plus 24, x subtract 4, that will give you your difference of them is 20, gives you 20. And so thus we can find our solution. So x is not going to be negative 24. We can't have a negative number of blue counters. So this means that x equals 4. So the number of blue counters, so we're going to have 4 blue counters. If you wanted to double check, so if we had 4 blue, that would mean we would have 8 red, so it'd be 12 in total. So the probability of getting a blue would be 4 out of 12. Then to then pick a red on the next one, there'll be 8 left, so that'd be 8 over 11. So if we just do some cross cancelling, so what we end up with here is that's actually 4 over 12 is a third. So we end up with 8 over 33. That's the probability of getting one of each, just with a blue first. So you can see that if you'd multiplied that by 2, you would get 16 out of 33. So we've got the correct answer. So well done, there's a lot of algebra there. I hope you did okay on that. If you're feeling confident, why don't you have a go at Spicy 100 question 5.